Those gases and the pressure could blow right through that gasket. So as soon as there's any kind of 1,000 degree, 2,000 degree gas fire. Hey guys, welcome back. Steve here with 6 Star Automotive. Today I'm going to talk about something that all Subaru owners are very well aware of. I'm going to talk about what they do, how they work, how they fail, and what you can do to prevent it. But before we get started, as usual, like, subscribe, hit the bell, and join me as we talk about head gaskets. Pretty much everybody has heard the term head gasket or blown head gasket, but you may not exactly know what that means. So let's take a look at this diagram and get an idea of what we're talking about here. So this would be the head that you're talking about, or the cylinder head. So you have a cylinder which is going to house the piston and allow for that combustion event to happen. The block, which is what the pistons are housed inside of, and then the head, which bolts to the top of the block. Now you can see this black line right here is depicting the cylinder head gasket. The job of the head gasket is to seal the surface between the block and the head. There's a lot of things that are going on right here, and it's a very, very important job. Before we get too deep, you guys know I love New Mind. These guys are amazing. The detail that they go in is far more than I can really manage in the short kind of videos I'm trying to make. But check out this video from these guys. It is incredible. If you want to know the real super duper detail as to kind of how these things work. So if you've watched any of my videos so far, you should probably know kind of how an internal combustion engine works. Right? You have the piston that goes up and down inside the cylinder. You have 4 specific strokes: intake, compression, combustion, and exhaust. So as all of those things happen, this gasket has to make sure that the surface between those two components stays the same and can withstand all of those events simultaneously. And then if you kind of turn this engine sideways, I mean, if this is a 4-cylinder, you're going to have 4 of those events happening all the time. So after the vacuum that's created by the piston being pulled down draws in the air in the fuel mixture, that valve will close as the piston comes up. It compresses the air and the fuel inside of the cylinder right at where that head gasket sits. The compression event happens right there. So the head gasket has to be able to handle all that compression and the combustion event itself. So you're looking at very easily over 1,000 psi, and the combustion event can easily be 2,000 degrees. Ideally less than that, NOx emissions, all that stuff. Anyway, the head gasket has to be able to keep that combustion event happening inside the cylinder only and not blow out the side or blow out in between the 2 cylinders. One thing that you can't see in this diagram is that there's a lot of passages in here. This isn't actually solid metal like it shows in here. This is hollow, and there will be a lot of coolant in here, which is what keeps the engine from overheating or melting. All that combustion and all that heat inside of here gets absorbed into the engine coolant that's wrapped around the jackets of these individual cylinders. And so the coolant has to be able to pass in and out of the head through the gasket itself, and so does the oil that has to go up to the valve train and keep all those components lubricated. So not only does it have to seal that combustion event and keep it from escaping, it has to keep it from leaking into the oil from leaking into the coolant from leaking into the combustion chamber. All that stuff has to stay where it's supposed to be and not intermingle with things that it shouldn't be intermingling with. And if you think about that even for a second, it's like, okay, so we have 1,000 degrees over here. Coolant is usually about 190, 200 degrees. Oil is generally about the same. The pressure in these systems is completely different too. Compression event could be 1,000 psi. The pressure in the cooling system is only about 16 psi. And then the pressure in the oiling system is generally 40 to 80 psi. So it has to be able to handle all those different things in one specific area. It is an amazing piece of technology that this thing can actually work at all. And with a Subaru specifically, you have to take this engine and turn it on its side. So Subarus don't have reciprocating engines that go up and down. They go side to side. They kind of push out and push in. So if you took this thing, put it sideways, and now you have to imagine the oil and the coolant pooling on one side. We'll get to the Subaru specific stuff in a second. I want to go over this first. So why do head gaskets fail? Well, I mean, from what we talked about already, it makes perfect sense why they would fail all the time, right? But generally speaking, what ends up happening is an overheat event is what causes head gaskets to fail. And that happens because of what's called head lift. The head is bolted to the block by what are called head bolts. As metal components heat up or overheat, in this case, the head can actually warp. and it can kind of twist, which will then lift the head away from the block even momentarily. I mean, you can imagine how many of these events are happening. From the video that I did on the timing belt, you can see how fast all those pistons are going up and down. If that head goes boop for even a microsecond, those gases and the pressure could blow right through that gasket. So as soon as there's any kind of 1,000 degree, 2,000 degree gas fire that torches right past that gasket, it's over. The head gasket is blown and you have to remove the head in order to fix it. Other things that can contribute to head gasket failure are lack of cooling system maintenance. You got to think about the head gasket generally is a metal gasket. The coolant is really what protects all of the metal in the engine, and especially that really thin gasket. So what are some signs of a failed or blown head gasket? So anytime that there is a coolant leak or an engine overheats, there's always a possibility of head gasket failures. So doing something like a block test, which involves checking for carbon dioxide in the cooling system, which can only get there through exhaust gases entering the cooling system, is necessary in order to look for the evidence of a blown head gasket when doing repairs like that. A blown head gasket can actually cause overheating to happen because you're pumping air into the cooling system, which displaces water, and then overheating events can occur. So you can actually have an overheat because of a blown head gasket, as well as a blown head gasket because of overheating. They can kind of... So white smoke out of the exhaust, usually first thing in the morning, is going to be another thing that give you signs. It doesn't mean that it has a blown head gasket, but it does. If you have a couple of these things at the same time, you want to look into doing a block test and a compression leak down to pinpoint exactly what's going on. Hard starting in the morning, so if you have a crank no start, or if you have a long crank, and then it runs, and then you get white smoke, you should have that head gasket checked. Milky oil is another thing. Like I said before, if a head gasket fails, the oil and the coolant can mix together. So if you have milky milkshake oil, then the likelihood of head gasket failure is pretty high. Consuming coolant without any visible leaks is another thing that would give us an idea that there's a potential head gasket failure, because the coolant has to be going somewhere. If it's not leaking outside of the engine, it could be getting consumed inside the engine. So why do Subaru head gaskets fail so often? So this is something since about 2013 that hasn't really been an issue, but all the Subarus pretty much from '99 up until 2011, Subaru head gaskets that was something you had to deal with every 60,000 miles no matter what. We actually still stock a lot of stuff to do those because there's a fair amount of them still on the road, and I have a bunch of them myself as my loaner cars. But what caused that to be such a problem? So like we talked about before, one of the issues being that the engine is sideways, right? So you have oil that pools on this side of the engine all the time. On a standard inline or V-type engine, the oil will always fall down to the pan, and nothing really ever sits on that gasket area. So what we find with Subaru head gaskets is they generally will tend to leak oil first, and it's always right where it pools. The original Subaru design was a single layer gasket with a composite, like a Teflon kind of coating on the outside. There's kind of a give and take with that situation. So the issue is that the gasket relies on that coating in order to seal the surfaces. That coating doesn't react very well with the oil over time. It eventually kind of seeps its way into that Teflon coating and through it, and then leaks out the bottom. The solution that they ended up coming up with that was using an MLS, or a multi-layer steel gasket. That seemed to completely solve the problem with the oil leaks. However, what we found is that the MLS gaskets seem to have integrity failure a lot more than the single layer gaskets with the coating on them. So the single layer gaskets seem to be a lot more forgiving when it came to head lift, overheating, stuff like that. The MLS, not forgiving at all. So what basically, to boil it down, the MLS gaskets tend to have a higher propensity to blow, and the single layer original gaskets will eventually leak over time. So our recommendation has still been to stick with the factory gasket. I mean, you're going to do the gaskets every 60,000 miles, but if you do a multi-layer steel in order to try and stop the oil leak problem, you can get, 2 years, 3 years down the road, if anything happens, if you have a coolant leak from a radiator that got nicked by a rock or whatever, and that engine overheats just the smallest bit, bang, the head gasket's gone. So the factory ones seem to be a bit more forgiving to that kind of stuff. So is a blown head gasket in a Subaru the end of the engine? Not necessarily. We've been able to put many, many engines back together that have had failed head gaskets because of overheating conditions. The blocks tend to be rather robust. They don't really have that many issues. It's the heads that tend to warp, which is great because those are pretty easy to fix. The block, that's a different story. So machining, cleaning, resealing, they tend to work just fine after that. As a disclaimer though, one thing that we have found that has caused the most problems is inexperience when it comes to previous work in the past. Improper torquing of the head bolts can cause the next time someone goes in to have a really big problem. Those head bolts have very specific torque patterns and very specific sequences, and if it's not done right, the aluminum threads that are in the block can be pulled out. And we've had zero luck with rethreading the aluminum threads inside these blocks. At this point, if we find the threads inside the block are no good, we don't go any further. We recommend engine replacement. That's something to kind of keep in mind. Again, a lot of this really isn't applicable anymore. Since, like I said, since 2013, 14, 15 and on, they don't have this problem. They changed to the newer FB engine type. They switched over to MLS, they switched over to timing chains, and we've seen almost no issues with head gasket failure. So good job, Subaru, finally. So if you have one of these older Subarus, what can you do to prevent this kind of failure? Like I said, with the oil leaks, there's really nothing you can do to prevent it. I mean, that's just part of the design. The oil pools, it's going to eventually get past that Teflon. But proper maintenance, proper maintenance of the oil, proper maintenance of the cooling system, that's going to give you the best longevity that's possible. The second thing for the best longevity is when they do need to get replaced, having someone that knows what they're doing do it. We have very specific processes and very specific parts that we use when it comes to these head gaskets that I've seen very few other facilities use. So we go by the Subaru specific processes and steps, and we also use the same parts that Subaru uses. So we have a very, very, very low comeback rate when it comes to this specific repair. All right, guys, I hope you learned something from this. If you have any questions, comments, or head gasket related stories, leave me in the comments section below. I'd love to hear them. Always stay on top of your preventive maintenance. Check out the rest of our videos on YouTube. And remember, you can always come on by to experience the 6-star difference for yourself.